The last thing we're going to talk about is called the standard score, or also known as the Z-score. And this pertains to any kind of distribution that is this right here. If a distribution is shaped in a bell-shaped, or if a distribution is normal, we can use a Z-score. The value of the Z-score, the Z-score represents the number of standard deviations. That's all this is. So it's a number of standard deviations above or below a mean. And if a value is bigger than the mean, we expect it to have a positive Z-score. So this means that the value is, positive Z-scores are going to be greater than the mean. Negative Z-scores are going to be less than the mean. And we use Z-scores to compare different distributions with different means and different standard deviations. But all a Z-score is it tells you how far above or below the mean you are. And we're going to get more detail into this later on when we get to normal curves. But right now, you can think of it as it's taking the standard deviation of each distribution and trying to sets the mean at the center, and it tries to use the standard deviation to tell you how far away from you are from the mean. So here's an example of how we use this. Suppose that a college admissions office needs to compare scores of students who take the SAT with those who take the ACT. Suppose that among the college applicants who take the SAT, scores of a mean of 896 and a standard deviation of 174. Further, suppose that among the college applicants who take the ACT, scores of a mean of 20.6 and a standard deviation of 5.2. We're going to assume that these distributions are normal. And it gives us two applicants here. Erica has a 1080 on her SAT, and Sam has a 26 on her ACT. They're competing for a scholarship. So with those two scores, here's what it essentially boils down to. If you were to sketch these normal curves for both those students, so here's Erica's normal curve, right? Where her mean is set at, the mean of this distribution is a 896. So her curve is set at 896, and Sam's curve is set at, well, this is the SAT curve, and this is the ACT curve. And these are just normal curves. We know that a normal curve, the mean lies at the center of the curve, and then we're stretched out by the standard deviation on each one of these. So this mean is at 20.6. Now, we're comparing the values on both these curves. The first curve is going to be a 1080, which sits somewhere out here. And then on the other curve is going to be a 26, which sits also somewhere out here. So this is essentially what you're having. You're trying to see which one is better based off of these curves and their standard deviations. Well, to find a Z curve or a Z-score, all we do is this. Z is equal to x minus the mean divided by the standard deviation. This will standardize any curve. And what it does is it makes it into one giant curve that has it makes it into one giant curve that has a mean of 0 and a standard deviation of 1. So every one of these standard deviations is now this. And what you want to do is take the information that was given to you. So we look at Erica's score. She made a 1080. Minus the observation she made was 1080 minus the mean of that curve, which was a 896, divided by the standard deviation, which was 174. This is her Z-score. And to calculate that, we get a Z-score of 1.057. On Sam's test, she had a z-score of, she had a 26 minus the mean, which is 20.6, divided by her standard deviation, which was 5.2. We get a value of 1.038. So what that means is that both these dots are going to fall on this z-curve. One falls a little bit more than 1 right here. That's Erica's score of 1.057. One falls a little bit closer to 1 right here. That's Sam's score of 1.038. So you can see, based off of this curve, we standardize both these values back to what is known as a z-curve or a standardized curve. And the one that's bigger is going to be this one right here. So she should get scholarship based off having a better grade. Now we can do this for any other problem besides not just scholarship, but when we want to compare more than one distribution, we look at these curves right here. And we find these z-scores right here. Z-scores are the number of standard deviations above the mean. So here for this curve, you're 1.057 standard deviations above the mean. For this curve, you're 1.038 standard deviations above the mean. And notice that both their values sit above the mean. So just remember, when you talk about a z-score, you're talking about standard deviations above the mean.